Dear students, in this video, let us study about LR parsing, which is also called as simple LR. First, L stands for reading the input from left to right, and R stands for we will get RMD in reverse. In the previous chapter, we have studied about LL parsing, which is used for implementing predictive parsing. Now, let us implement bottom-up parsing with the help of LR parsing. In the last video, we have studied about shift reduce parsing, isn't it? So now it is an advanced method of shift reduce parsing. Then which type of grammars can be used for LR parsing? That is just CFG. But for LL parsing, we have studied that the grammar should be free from left recursion, left factoring, ambiguity, etc. But here there is no restrictions like that. We have just CFG. So another advantage of LR parser is like it can detect a syntax error as soon as it is possible to do so on a left to right scan of input. Now, what are items and LR of 0 automaton? We know about automaton. Automaton consists of some states, transition, then start state, final states, etc., which is used to recognize the string. So, how it is helpful for implementing LR0 automaton? Main advantage of LR of 0 automaton is to know about shifting decision, that is when to shift and when to reduce. So this LR parser makes shift reduce decisions by maintaining states to keep track of where we are in the parse. Here we will use a dot. Dot plays a very important role in LR of 0 automaton. This state represents sets of items. So LR of 0 item of a grammar G is a production of G with a dot at some position of the body. Now consider one example like A gives XYZ is a production. This particular production yields 4 items, that is A gives dot XYZ. Means we can have a dot in the beginning, a dot followed by XYZ, or X dot YZ, or xy dot z, or finally xyz dot. So what is the meaning of dot over here? So it is very important. If you can see a dot in the beginning, then it meant that we have to know about the strings which are derivable from xyz. Then x dot yz means we have just seen the strings derivable from x, but we have not seen about y and z. Xy dot z means uh, it's like previous case, we have known about x and y, strings derivable from x and y, but we have not known about strings derivable from z. So this is important last one, that is A gives xyz dot. A dot at the end means now the string which is ready to be reduced to start symbol A, where A is our start symbol. So XYZ dot means everything is ready with us now. The strings derivable from X, Y as well as Z. Now it is in the position to reduce XYZ by start symbol A. Now how these items are constructed and how the items are important to construct an automaton, which provides the basis for constructing deterministic finite automaton that is used to make shift reduce decisions. We have two functions over here, closure and goto, which play very important role in the construction of LR of 0 collection of items. Closure. First let us see about closure. If I is set of items for a grammar G, then closure of I is the set of items constructed from I by two rules. What are the two rules? Initially, we have to add every item with a dot in I to closure of I. If I is the given set, then we have to add every item with the dot to closure of I. We'll see an example. Then this is the first rule. Second rule, if there is an production like this, A gives alpha dot B beta, where B is a non-terminal. Okay, it's very important, where B is a non-terminal, which is in closure of I, and B gives gamma is a production. Then what we have to do is we have to add item B gives dot Y. We have to place a dot in the beginning to closure of I if it is not already there. So we have to apply this rule until no more new items can be added to closure of I. Okay, there are two rules. First, we have to add every item with the dot into closure of I, and second one, if this is there in the item set, A alpha dot B beta, if B is a non-terminal, then the production of B should be added to closure of I with the dot followed by the production to the closure of I. Consider this example where E gives E plus T or T gives T star F or F gives E or ID. Find closure of E. So how it can be solved? Now, suppose there are two productions from the start symbol like this, E plus T or T. So the parser will get a confusion about when to reduce right hand side production by start symbol E. That is whether T must be reduced to E or whether E plus T must be reduced to E. To avoid this confusion, if we have two productions from the start symbol, we will construct augmented grammar. So that augmented grammar means the when exactly the right hand side has to be reduced by the left hand side. That is, when the right hand side contains only one production, then only it has to be reduced to the start symbol. So how it can be converted into augmented grammar? That is, let us introduce a new start symbol like this E dash, which gives E. Let us write like this. Now E gives E plus T or T, something like that. Now this is called as augmented grammar. So how to compute closure of I? So which is our first production? First production is this one. E dash gives E. So first add this particular production with the dot in the beginning. So E dash gives dot E. Okay. Then when this is added, you can observe one thing. Our dot is followed by non-terminal E. When it is followed by non-terminal E, I mean it is according to our second step, we need to add the productions of that particular non-terminal. That is E. We have two productions from E, that is E plus T as well as T. Now add E plus T and T with the help of dot. So it becomes E gives dot E plus T and E gives dot T. Now once again you can observe dot is followed by non-terminal T. Add the productions of T with the help of dot. T gives dot T star F, T gives dot F. Now once again dot is followed by F, again non-terminal. So add the productions of F with the help of dot E and dot ID. So this entire set is called as I, closure of I. Suppose if you call the given grammar as I, then closure of I is this one. This is how to compute the closure. Now the same thing is explained with the help of algorithm over here, how to find out set of items closure of I. So for each item, for each production alpha dot B beta, then for each production of B, we have to add B gives dot gamma into the new set of closure I. So until no more items are added to J on one round, then return means here you can stop over here because all the productions are over, as well as dot is followed by a terminal, dot is followed by a terminal over here. Then we have to stop. This is how to compute closure. Then one more thing here. actually items can be classified into kernel items and non-kernel items. What is a kernel item? Kernel item is which is an initial item, that is s dash gives dot s, where s dash is a new non-terminal which is introduced by us, and s is the start symbol given by the author. So uh, initial item is called as kernel item, and item whose, as well as some other items whose dots are not at the left end. Then what is non-kernel item? All items with their dots at the left end except for this. That means this non-kernel item is added to the list only because of the kernel items. Now consider the same example. Here the first item e dash gives dot e is called as kernel item. Now remaining 3 plus 3, remaining 6 items are called as, these 6 are non-kernel, because we have added these 6 items only because of kernel item. That is, a dot is followed by non-terminal. That's why we have added remaining things. Okay, so kernel item is the first item. Non-kernel item is the item which is added because of the kernel item. Like that also we can say about kernel and non-kernel item. This is the formal definition. Items having their dot at the left end, items having not having dot at the left end, like that. Now another function. As I told earlier, there are two functions which we require to construct automaton. First one is closure and second one is goto. What is goto? What is the function of goto in the construction of automaton? Let us discuss now. So goto of I comma x. There are two symbols over here, I as well as x. What is I? It is nothing but item. X means each and every grammar symbol. So function goto is helpful to define the transitions for the LR of 0 automaton. So here I is the set of items and X is the grammar symbol. So it is defined to be the closure of set of all items A gives alpha dot X beta is in I. Let us consider one example. So before that, the states of automaton corresponds to the set of items. State means items and goto specifies the transition. So this is an algorithm for constructing LR of 0 item. See here, first find out closure. Okay, you have given with the grammar, then first find out closure of the start symbol, like this. If this is the production given, A gives E plus T or T, okay. This is the grammar given for you. E gives E plus T or T gives T star F or F, E gives E or ID. Then how to find out the function closure and goto? Closure is this one, we have already computed. Now what is the goto? How to find out goto? Suppose we need to find out goto of dot E plus T. Okay, see here, goto of this one, goto of dot E plus T, means we are moving this particular dot towards right one position. So after finding out goto of this, you will get E gives E dot plus T. See, initially we have dot here, here we have dot. Now after goto, this dot will move one position towards the right. Now this is our dot. In detail, let us study the algorithm. Okay, closure has been found out first. Then for each set of items I in C, for each grammar symbol, find the goto. If goto of I comma x is not empty and not in C, then add. until no new sets of items are added to C on a round. Let us see the problem now. Then only you can understand what is closure and what is goto. Construct LR of 0 automaton for the following grammars. This example I will explain now. The second example you have to solve. Okay, now first what we have to do, we have to find out augmented grammar. So augmented grammar is written over here. Grammar is SA or A gives A. How many productions? There are 3 productions. So from the start symbol, there are 2 productions. So we have to write augmented grammar like this. S dash gives S. S dash gives S. Then this S gives given production SA or A. Then A gives A. So this is the augmented grammar now. That is the first step. Now we have to find out closure of start symbol. Our start symbol is S dash. So this is I naught. Let us call it as I naught. How to write I naught? S dash gives dot S. Please remember we have to put a dot in the beginning for finding out the closure. Then S gives dot SA, S gives dot A gives dot A. Okay. This is called as I naught. Now we are in a situation to find out goto. Goto of I naught comma yes. Why we have to write yes? Because consider the first one. Let us move from first production towards the last production. First production dot is followed by yes. Okay, a dot is followed by yes. So goto of I naught comma S, which is called as I1, a new item introduced by S, which is I1 now. What is I1? Now define, this is just a name I1. Now what are the items belonging to I1? I1 is given by S dash gives S dot. Why it is S dot? Now dot is moved one position towards right. Okay. In the beginning dot was here. Now dot is moved towards right one position. It is not over because in the second production also you have a dot followed by capital S. 2 productions are there, dot followed by S. Add that production also. S gives S dot A. Why? Because that dot, this dot is moved towards one position right now. So it is S dot A. Then A gives dot A. Why it is added? It is added because, just observe here, S dot A means dot is followed by a non-terminal. Okay, remember the rule. When a dot is followed by a non-terminal like this, we have to add the productions of that non-terminal. So A gives dot A is added. So this completes our set I1. I naught is completed, I1 is also completed. Now dot followed by S. Goto of I naught comma S is over. Now goto of I naught comma A. So goto of I naught comma A is called as I2. How to write I2? See, dot A is here, S gives dot A. So we have to move this dot towards right one position. So it will become S gives A dot. That is I2. Only one production where dot is followed by capital letter A. So it is over. Similarly, go to of I naught comma small letter A, which is called as I3. So I3 is nothing but A gives A dot. This completes our I naught set. I naught closure, I naught is here. Then all goto functions. Goto functions has to be written where dot is followed by a non-terminal or terminal. So goto for I naught comma S, goto for I naught comma A, goto for I naught comma small letter A. Now coming to next set, that is I1. What is there in I1? There are three items like this. S dash gives S dot, S gives S dot A, and A gives dot A. See, the first one, dot is already at the end, so that is finished, no need to proceed further. But in the second item we have S dot A, so goto of I1 comma A has to be written. Remember, we are in the item set I1, so goto of I1 comma capital letter A. Why? The dot is followed by capital letter A, so goto of I1 comma A is called as I4, so SA dot, because this dot is moved towards right one position. Then I1, goto of I1 comma small letter A, which is called as I3, that is A dot. So I0 is over, I1 is also over. Now I2. Consider I2, as I explained you before, where is dot? Dot is at the end, so that is finished. Next, I3 dot is at the end, that is also finished. I4 dot is at the end, so I4 is also finished. So when we have to stop, when dot is at the end, we have to stop. So this is called as a LR of 0 item sets, or canonical collection of LR of 0 items. Now with the help of this, we have to construct an automaton. This is the automaton. How it is constructed? Consider I0, which is the start state. I have mentioned over here I0. Write I0 and write all the items like this. Then keep on watching goto functions. Goto of I0 comma S is I1. So I0 on S, go to I1. Then from I1 go to, okay, not over, I0 comma S is over, I0 on A, that is I2, I0 on small letter A is I3. So just give the transition using the items which have been constructed before. Then you can see one important thing over here. On I1, arrow mark on transition dollar, right, accept. It is the special case where you have S dash gives S dot. S dash is the start symbol and S is the given start symbol. S dash is the new start symbol, S is the given start symbol. So when the string is ready to be reduced to start symbol S dash, that is the final state. So write from I1 on dollar, right, accept. This is the start state and this is the accepting state. This is about LR of 0 automaton. Now one more thing you can observe here, how to construct SLR parsing table. You can see a table here where the rows are about this item set 0, 1, 2, 3, 4 like that, and columns we have two parts, action and go to. Under action all the terminals and dollar, under go to all the non-terminals. So we'll see the model of LR parser, very important. Here in the LR parsing program, this is the program or the algorithm which takes different parts. First part is input. Input is the string which is given to you. For example, ID plus ID star ID, something like that. Then there is a stack for temporarily holding the inputs as well as the states. Then this is the table actually, action and go to. There are two parts, action and go to. Okay, so let us see how to construct this table in the next part. This is an algorithm to construct a table. See here, what is the input? Input is augmented grammar. Okay. Then what is the output? SLR parsing table with action and goto. How exactly it is constructed? Observe the first step. Construct I0, I1, IN, the collection of set of LR of 0 items, means like this. So this is our first step, constructing LR of 0 items, this one. Okay. I0, I1, etc. This is the first step. So after the first step, what is the second step? State I is constructed from II. Means if we have I0, I1, I2, I3, then your states are 0, 1, 2, 3. Okay. I0 means 0, I1 means 1. Now passing action. These three are the very important points now. You have to see where is dot. Means here if the production is of type alpha dot A beta where A is a terminal. Okay, give importance for such type of productions only where a dot is followed by a terminal. Or see the second one where dot is at the end. Okay, dot is followed by terminal, give importance, and dot is at the end. Other type of productions just you can leave. Then this is the special case. S dash gives S dot. It then set the action of I comma dollar to accept. So if it is the case, then action is shift. If this is the case, then action is reduce. Then last one, accept. Other things are considered as error. Okay, please remember we have 4 different actions similar to our shift reduce parsing. When to shift, when to reduce, when to accept, and when error occurs. So here shift case occurs when a dot is followed by a terminal. Okay, when a dot is followed by terminal, then shift. When a dot is at the end, then reduce. And this case is accept. Other cases are considered as errors. Then about goto. So we have different goto functions here. Goto of I0, S, goto of I0, small letter a, capital letter A, etc. So these goto functions are directly copied to the table. Let us see one example. Okay, here. This is the table which we are going to construct now. Okay, so one thing. Okay, here. All the rows 0, 1, 2, 3, 4. The rows are constructed according to the number of items. Columns, there are two parts, action and go to. Action means terminal followed by a dollar which indicate the input end marker, and go to all the non-terminals in the given grammar. Only S and A are the non-terminals. No need to consider augmented grammar, just consider given grammar. Okay, then you can name the productions like this. S gives SA is the first production, S gives A is the second production, and A gives A is the third production. 1, 2, 3. Give the number like this. Then, so consider I0. In I0, is there any item having dot followed by a terminal? Okay, give importance for only the productions having dot followed by terminal. Yes, we have a dot followed by terminal, that is A gives dot A. In that case you see what is goto of I0 comma A. Goto of I0 comma A is I3. If that is the case, then action is shift. So we wrote 0 on A is S3. Okay, understood? No? From I0, observe the productions where dot is followed by a terminal. We have production over here. A gives dot A. Then see its goto. Goto of I0 comma small letter A is I3. Then action is shift. So I wrote S3 means shift 3. Why 3? Because it is I3. Okay. From I0 we have only such type of production. Then we have different gotos. Goto of I0 comma S is I1. So from state 0 on S go to 1. Just write 1, and 0 on A is 2. So it is written according to this one and this one. capital letters means non-terminals, directly write the goto. So I0 set is completed. Now coming to I1. Where is I1? I1 is here. I1 is having S dash gives S dot according to our third rule. Here, okay, third rule, S dash gives S dot. So action is to accept. So 1 on dollar is accept, we wrote. 1 on dollar is accept. Then I1 contains one more production. A gives dot A. See here, dot is followed by a terminal. So action is shift 1. 1 on A is shift 3, similar to the previous case. Then one more goto is there. I1 on capital letter A, that is I4. So 1 on A is 4, we wrote. Then coming to I2. Yes, I2. I2 is here. I2 is having an item S gives A dot. A dot means dot is at the end. If dot is at the end, then the action is to reduce. If the action is reduced, you have to find out follow of non-terminals. We have two non-terminals here, S and A. So follow of S and follow of A. Follow, what is follow of S? S is our start symbol. So follow of S is dollar, as well as S is followed by capital letter A here. Here capital letter A. So first of A is A. So follow of S is dollar and A. What is follow of A? A is at the end, so it is nothing but follow of S, so dollar and A. So we have formed follow set. Now, if dot is at the end, find out the follow of LHS, that is S, dollar and A. For those two terminals, we have to set the action as reduce. Reduce with which production? See the number. The S gives A is the production. Its number is 2. See here, S gives A. So the number is 2. So I wrote R2 and R2. Okay. Now I3. In I3 also we have A gives A dot. Dot is at the end. Find out follow of A. Follow of A is dollar and A. So for I3 means third row. A and dollar, under A and dollar, write R3. Why R3? Because A gives A is the third production. The number we have given for that production is 3. So R3. Now last one I4. I4 is having S gives SA dot. Dot is at the end. So action is reduce. Reduce with which production? Reduce with the first production. So R1 and R1. This completes our table, SLR table. SLR means simple LR table. Now LR parsing program, an algorithm. How to check whether the string is acceptable by the table or not. So that we have to check. For that purpose, we have another algorithm. So here A be the first symbol. If string is A, then first A will be the first symbol. Then repeat S be the state on the top of the stack. Means 0. Let us consider start state 0 on the top of the stack. Now if action is shift, like 0 on S, 0 on S is shift, then push that symbol onto the stack and advance the input pointer. A be the next input symbol. If the action is reduced, then we have to take care, pop some symbols from the stack. That depends upon how many symbols are there on RHS. If production is A gives A, then there are two symbols, so we have to pop two symbols. If the production is A gives A, then we have to pop only one symbol from the stack. So that's why pipeline symbol with the beta. Then let it state T be now on the top of the stack. See the goto function of it and output the production. Otherwise, else if action is accept, then parsing is done. If not, then call error recovery routine. Let us trace this example. Okay, here. This is a table which we have constructed already. Now consider the string AAA. If the string is AAA, see here on the stack we have 0, input is AAA. So 0 on A is action is shift. Why 0 on A? See here 0 on A is shift 3. So I wrote 3 over here. That A is copied over here. So next input is A. So next is 3 on A. What is 3 on A? 3 on A is reduced with the 3. See here 3 on A is reduced. So I wrote action is reduced. How many symbols on RHS? We have only one symbol, that is 1A. So pop this 3. So I wrote here pop this 3 from the stack. If you pop this 3 from the stack, our top of stack is 0. Next, this A is reduced to A. See here LHS. Instead of RHS, write LHS. So now see 3 is popped. Top of the stack is 0. So 0 on A is, that is 0 on A. 0 on A is 2. So instead of 3, after popping 3, we have 2. So now stack contains 0 and 2. So reduce action is completed now. Now 2 on A. What is 2 on A? 2 on A is reduced with the 2. So again I wrote reduce S gives A. How many symbols? Just one symbol. So that 2 is popped. Okay, 2 is popped. If 2 is popped, we have 0 on the top of the stack. A is reduced to S. See, instead of A, write S. A is reduced to S. Now 0 on S. See the right mark. 0 on S is 0 on S is 1. So I wrote 1. This step completed. Reduce action is completed. Now what to do? 1 on A. 1 on A is, see 1 on A is shift 3. So I wrote 3. That A is copied over here. Okay, this A is here now. Previous A. First A is here. Now 3 on A. Repeat the process. 3 on A is reduce 3. 3 means A gives A production 1, 2, 3 number. So reduce means pop the symbol. 3 is popped. We have 1 on the top of the stack. 1 on A is 4. See 1 on A is 4. So 4 is written. Reduce action is completed. 4 on A. What is 4 on A? 4 on A is R1. So reduce with the first production. Okay, like that we have to shift 4 on A is shift. So continue the procedure till we get either accept or error like this. So this is about LR parsing program. There is an example, textbook example. E gives E plus T or T gives T star F or F, E gives ID. We have to construct automaton by computing LR of 0 item sets, construct SLR parsing table and show the moves made by the string. Since this is textbook example, I will show you the snapshot directly. So this is the LR of 0 automaton where we have total 11 item sets, I11. Starting is I0, then after finding out goto of I0 comma E, goto of I0 comma T, goto of I0 comma ID, left hand parenthesis F, you will get different items like this I1, I2, I3, I3, I4, I5, etc. Then I6, I7, I8, I9, I10 as well as I11. Please solve this problem by yourself. This is the parsing table, action and goto. There are two parts. See, many terminal symbols we have ID plus star, left parenthesis, right parenthesis as well as dollar. Goto is ET and F. These are the actions shift or reduce. You can understand only if you solve the problem by yourself. This particular slide shows moves made by the string id star id plus id, stack, symbols, input as well as action. Work on it. These are the problems which are asked in the examinations. I referred video question paper as well as textbook problems. One or two problems I will solve and upload to the model. Other problems you have to solve. See here one note I have given. Shift reduce or reduce conflicts occur in problem 5 and 6. My dear students, please solve problem number 5 as well as 6. In these two problems you will get conflict in the sense for a particular table entry you will get two entries. So for example, here 0 on id is s5, isn't it? Okay, 0 on id is s5. Along with s5 you may get like this s5 or some r1 r2 like that, or S5 or S6. If you get two actions like this, shift or reduce or two shifts, then it is called as conflict. Shift reduce or reduce conflicts. So you will get conflicts for those two problems. So what we can say is these two grammars are not SLR grammar. We cannot pass these two grammars with the help of SLR parsing table. So this is about LR parsing, LR of zero automaton, LR parsing, etc. Please work on different problems I have given. I will upload the assignment into the model. Thank you, students.